Okay, kia ora everyone. My name's Nick, as Melissa said. I'm just going to give a really brief introduction to the outline of this presentation. So first I'll speak briefly about my own research for my PhD and some of the other work that we've been doing and how this feeds into what we've been doing with the Pacific community and SPC. I'll give an overview of the workflows involved and the different open source tools and data sources that we use. And then I'll talk a bit about the case study. And the case study in this presentation will be Tonga, where we did a land cover assessment skills transfer in 2023. I'll talk a bit more about the methods and then the results of this. So just a bit about me. I did a joint PhD program between the University of the South Pacific and the Australian National University. And so this research was mainly focused on spatial prioritization for environmental monitoring for hydrology and riparian ecosystem services in the Bar River catchment in Fiji. And so basically this involved some work. One section was on hydrology and waterways, one section was on riparian forest, and one section was on climate risk, and in particular the impacts of tropical cyclones. But in essence, a lot of my work just involved paddling around in the river, collecting water quality data, and doing a lot of water quality and hydrology equipment setups, and monitoring the hydrology of the catchment, as well as a lot of forestry work, a lot of forest inventory measurements, and this kind of work. And this led into some carbon stock assessments, and that involved land cover assessments as well. So we did a land cover model for Fiji, and we actually formed a team with some of the universities, like the University of Fiji, the University of the South Pacific, and Fiji National University, and we were able to win a competition to use satellite open access and open source satellite data and workflows to monitor carbon sequestration. And with the funding we got from this project, we've actually used that to build timber and fasteners to build these nurseries for environmental tree planting. So this is some of the work, the impacts that have come out of the research itself in terms of more concrete on the ground impact. And this was the nursery in the village. And so the trees that we grow in the nursery can be used for environmental plantings that help to strengthen the riverbanks and reduce erosion. So this is just an overview of my research, but the focus of the presentation today are the open source geospatial workflows and data sources that we've used so that it can be useful for you to replicate as well. So firstly, in terms of data sources, I'm going to go into more detail about this, but we rely primarily on stack catalog datasets for satellite imagery, Microsoft Planetary Computer, Elements 84, and Digital Earth Pacific, and I'll go into more detail about this. Secondly, the scaled GeoMAD, so the geometric median and median absolute deviations product, which is kind of like a cloudless mosaic that's been developed to be statistically robust for our analyses, also generated through a cloud native platform of Digital Earth Pacific and Kubernetes workflows. And then finally, the machine learning workflow, which is used to generate the predictions. And this is an iterative process where we use the QField to collect the field data points, and then we use those field data points to train the machine learning model. And so I'll go into more detail about all three of these workflows through the presentation. But just first to give this context, so I work with SPC. SPC is the Pacific Community, which is a regional science and technological organization that helps support the Pacific Island countries and territories to access basically technology and scientific insights through capacity building and policy guidance. Back in 2020, 2021, there was a needs assessment conducted with many Pacific Island countries and territories to ask them, what do you need satellite data for? How can satellite data support your national priorities? And so there were a few priorities that were highlighted. In Tonga, for example, one of the key priorities that was highlighted was land cover because they were very interested in, for example, the agricultural census and forestry. So land cover, in this context, we're talking about the land sector, agriculture, forestry, and other land uses. And for simplicity's sake, for this particular workshop, we focused on the IPCC land cover classes. So this is a very simplified list of classes, so forest, crops, grassland, wetlands, settlements, and other lands. So we held a workshop in 2023. This is some of our team, and this was about supporting Tonga to update their land cover maps, since they hadn't done a land cover map since back in 2007, I believe. And so this was the first Digital Earth Pacific workshop for land cover assessment skills training. It was a one-week workshop composed of computer labs and fieldwork. So the fieldwork itself involved going out with the different government ministries we worked with and collecting field data using QField. And so there's been a lot of workshops this week about QField and some presentations as well. So we're lucky to have a lot of the developers here, so it's been great meeting them. But this is just a use case. So we went out and we collected GPS points for cropland and forest, for bare lands and mining areas and coastal areas. And we also used QField to do some coastal habitat mapping, and as well for grasslands and savanna. We'd done some work in the past on land use, land cover using some annotations, and this is Earth Engine. This was quite a while ago, but we had some preliminary results. But when we used QField, working with the local government in Tonga, we were able to go out for a day, and all of the participants, about 25 participants, were able to collect these data points all around Tongatapu, the main island, and using these data points from QField, ingesting them into Digital Earth Pacific, we were able to generate this machine learning prediction of land cover across Tongatapu, which was much more, had a lot more precision and captured a lot more of the complexity of the land cover than the previous work we had done in Google Earth Engine. So back to the workflows and the methods. I just want to touch briefly on Digital Earth Pacific. So Digital Earth Pacific is basically a public technology infrastructure. It's based on the same models as Digital Earth Australia, Digital Earth Africa, and recently they've developed a lot of the work from Geoscience Australia, working with partners in Africa. And more recently there's been work on Digital Earth Antarctica and Digital Earth Latin America, I believe. But in essence, Digital Earth Pacific provides this cloud technology infrastructure and provides petabytes of, hundreds of petabytes of data of satellite data, Landsat and Sentinel, a lot of computational capacity, and we also provide a range of services. So there are regional products that we've developed through some of the workflows. That we've done capacity building with more than 10 Pacific Island countries and territories, and a lot of policy guidance, as well as awareness and outreach. And this is all funded through development support from Australia, New Zealand, and other countries. So it's an open source, open access platform. So it's not there's no fee for this. So a lot of this workflow is informed through the fieldwork, and we've really relied heavily on QField for this to support our cyclical workflows. And I'll go more into this, but basically we've basically worked with the local governments to build these QField forms, go out to the field and do surveys, and then use the points, upload them to QField Cloud, and then use those data points and ingest them into our machine learning models. So in terms of the data sources for the satellite data, we've relied originally on Microsoft Planetary Computer Stack Catalog Elements 84, but we've also, working with Alex Leith, have built this GeoMAD product, which is kind of like a cloudless mosaic. It's a GeoMAD and median absolute deviation, so it's kind of more statistically robust. And this is ingested as a stack item or a stack collection within the Digital Earth Pacific on the Amazon Web Services. So basically, we use ODC, Open Data Cube, queries to access different satellite images and use those as our main data source for this work in X-array. So, a fun fact, I just learned that element 84 is polonium, which is used in thermoelectric generators in space. I didn't know that, but that's a fun fact for you all. Okay, so the scaled geomad, so through this process of working through the cloud native environment and the compute that we have through the Dask parallelization, we're able to scale these products across the Pacific. So this cloudless mosaic is what we use to generate the land cover map. And again, this is the geomad and median absolute deviations product that Alex has helped us build. Now, in terms of the QField approach and building the machine learning models, as mentioned, we collect field data points. We use QField and QField Cloud. We then take these points and overlay them over the satellite data. And then we sample values that could be spectral values, textural values, and variability values, and use these to train a machine learning model. And these models then predict different land cover classes or coastal habitats over space and time. We have to do a lot of validation, accuracy assessments with new field data, and so it becomes a cyclical process where we have to rinse and repeat through this cycle, and we hope that each time that we go through this cycle, our models will improve in terms of their accuracy and precision. And so this is what we did in Tonga, but we've also done this we've done this in Fiji, in the Marshall Islands, for Palau and Tuvalu, and Cook Islands. So it's something that we're continuing to do, working with our partners in each of these countries. And so for Tonga, these are what some of the outputs look like in more detail. And through that workshop, it wasn't just the results of the maps, there was also an intrinsic value of the participatory mapping and the two-way learning and capacity building that went on through that workshop using QField, as well as these other data sources and Digital Earth Pacific. Okay, how am I going for time? Yes, sir? 7 minutes, terrific. All right, so I also wanted to highlight that we used GeoPandas to help to kind of bridge between the simplified land cover typologies and the more complex land cover typologies. What we found was that through the workshop, there were different groups within the workshop with different interests in land cover, right? So we had, for example, the forestry department were very interested in the forest inventory work. The Ministry of Agriculture were interested in agricultural census. The Minerals Department were interested in mining areas. Fisheries were interested in coastal habitats. And the Disaster Management Office was interested in the impacts of hazard events. And so using GeoPandas, it just kind of helped us to streamline the process of either simplifying from these more complex classes on the right, that maybe, for example, the Ministry of Agriculture was interested in different types of crops, but if we wanted to simplify that, we could just group all the different crops into cropland using GeoPandas, and then the other way around is would be using another attribute in the form, the QField form, to then disaggregate all the different types of crops. And so another open source tool that was really useful for us was GeoPandas. I'm just going to focus on 2 case studies, the forestry, inventory, and the minerals. So for the minerals work, the outputs of this work were that the minerals department was really interested in looking at mining areas. And so we developed kind of a tool with them to monitor areas of quarries, bare land, and water to kind of identify mining areas and potentially illegal mining. And so through this process, through the land cover model, we could highlight and isolate these areas, the red being the quarries, the brown being the bare lands, and the blue being the water used in the industrial processes of mining, the tailings and dams and such. we tried a logistic regression or a max-ent model, but that had a lot of noise, and so we just switched over to a classifier, which helped us to reduce that noise to identify areas of stockpiles in red, and then potential areas where the river extraction was occurring in blue. And this is also aided by time series change detection, and we contributed this work to the Earth Observation for SDGs competition, and that was the SPC was able to get into the 3rd place for that and raise more awareness of this work. The other case study was forestry, and what we found was that through I think the participants in Tonga were most interested in the QField tool because they could use it for their own specific projects. And so Lotte in forestry was interested in doing coconut inventories, so she built a form just for coconut inventories. Tusolo was interested in the nursery production and distribution, so he built a form just for that. Mahe was interested in stock takes, so he built a form just to do stock takes across different nurseries around Tonga. And Sia was working on the 1 million trees project, and so she built a form to help with that. Sandalwood as well was another use case, and invasive species. And my colleague Eleanor Biokoto from Fiji will be doing a presentation on this invasive species work this afternoon. It was also supportive of the National Forest Inventory, which was a key use case. Great. So over the last 2 years, we've been doing two-way learning and capacity building in these workflows with more than 240 participants across 10 Pacific Island countries and territories. So this whole workflow of QField, taking the field data in the surveys, just loading that up to the cloud, QField cloud, and then ingesting those points into the Jupyter environment in Digital Earth Pacific, running GeoPandas to clean the data, and then using these open data cube workflows to actually generate these machine learning models and maps. And we've done a lot of research outputs from this. So we've published research on some of the work in Fiji, looking at land cover changes and deforestation. I did a work on a particular catchment looking at the drivers of deforestation using these QField and land cover approaches. And most recently, well, this is forthcoming, but we have this publication as well, looking at the impacts of tropical cyclones on tree cover loss. And so these are some of the research outputs that have come out of this work as well. So I think my time is coming to an end. So I just want to say thank you very much, and please stay connected. Okay, thank you.
This microphone's very low battery, so we'll see if it actually helps anyone. But does anyone have any questions?
I'm just interested in the relationship between the data collection and the machine learning environment. What sort of density of points or quantity of points do you need to get an effective result from that? And is this a pre-trained model that you've already pre-trained on other data?
Yeah, that's a really good question. Thank you for that. I think it's kind of a subject of ongoing research, but from my limited experience, what we found is that it depends on there is a statistical ratio of the area you're trying to do a prediction on to the number of points and everything. I don't have that off the top of my head, but I can take that on notice. But what we've found from our experience in the field is that you want to have a good, there's a few principles that we try to follow to get better results. And those, hopefully that's helpful. The principles were, one, having a good spread of different classes that's representative of the overall land cover context. So you don't want to have, 1,000 forest points and then 10 sand points, because that will skew the model. We also don't want to overfit. We don't want to collect too many points in just one class in one area. Another point was that because we're working with open access satellite data, we're working with Sentinel, it was a 10 meter by 10 meter pixel. And so we had to be mindful that each point we collected was at least more than 10 meters apart, if not more, to help us with that. There were more systematic ways to do the sampling, but because we had a one-day field trip for each of the workshops, and it was a very interdisciplinary group, we tried to just balance between best practice, but also making sure that we were able to collect as much data as possible. And then there was a process of cleaning and that kind of thing. So I'm not sure, that probably doesn't fully answer your question. Okay. Right.
Great. Thanks very much, Nick. Next, Please welcome President Alexis here.